Octane rating or octane number is a standard measure of the performance of a motor or aviation fuel. The higher the octane number, the more compression the fuel can withstand before detonating. In broad terms, fuels with a higher octane rating are used in high-performance petrol engines that require higher compression ratios. In contrast, fuels with lower octane numbers are ideal for diesel engines, because diesel engines do not compress the fuel but rather compress only air and then inject the fuel into the air heated up by compression, whereas petrol engines rely on ignition of air and fuel compressed together as a mixture without ignition, which is then ignited at the end of the compression stroke using spark plugs. Therefore, high compressibility of the fuel matters mainly for petrol engines. Use of petrol with lower octane numbers may lead to the problem of engine knocking. Principles: the problem, pre-ignition and knocking. In a normal spark ignition engine, the air-fuel mixture is heated due to being compressed and is then triggered to burn slowly by the spark plug and ignition system. If it is heated and/or compressed too much, then it will explode when triggered, or even self-ignite before the ignition system sparks. This causes much higher pressures than engine components are designed for and can cause a knocking, or pinging sound. Knocking can cause major engine damage if severe. The most typically used engine management systems found in automobiles today have a knock sensor that monitors if knock is being produced by the fuel being used. In modern computer-controlled engines, the ignition timing will be automatically altered by the engine management system to reduce the knock to an acceptable level. Octane is a reference standard. Octanes are a family of hydrocarbon that are typical components of gasoline. They are colorless liquids that boil around 125 °C. One member of the octane family, octane, is used as a reference standard to benchmark the tendency of gasoline, petrol or LPG fuels to resist self-igniting. The octane rating of gasoline is measured in a test engine and is defined by comparison with the mixture of 2,4-tremethylpentane and heptane that would have the same anti-knocking capacity as the fuel under test. The percentage, by volume, of 2,4-tremethylpentane in that mixture is the octane number of the fuel. For example, petrol with the same knocking characteristics as a mixture of 90% isooctane and 10% heptane would have an octane rating of 90. A rating of 90 does not mean that the petrol contains just isooctane and heptane in these proportions but that it has the same detonation resistance properties. Because some fuels are more knock-resistant than pure isooctane, the definition has been extended to allow for octane numbers greater than 100. Octane ratings are not indicators of the energy content of fuels, they are only a measure of the fuel's tendency to burn in a controlled manner, rather than exploding in an uncontrolled manner. Where the octane number is raised by blending in ethanol, energy content per volume is reduced. Ethanol BTUs can be compared with gasoline BTUs in heat of combustion tables. It is possible for a fuel to have a research octane number more than 100, because isooctane is not the most knock-resistant substance available. Racing fuels, AVAs, LPG and alcohol fuels such as methanol may have octane ratings of 110 or significantly higher. Typical octane booster gasoline additives include MTBE, ETBE, isooctane and toluene. Lead in the form of tetraethyl lead was once a common additive, but its use for fuels for road vehicles has been progressively phased out worldwide, beginning in the 1970s. Measurement methods. Research octane number. The most common type of octane rating worldwide is the research octane number. RON is determined by running the fuel in a test engine with a variable compression ratio under controlled conditions, and comparing the results with those for mixtures of isooctane and N-heptane. Motor octane number. There is another type of octane rating, called motor octane number, which is a better measure of how the fuel behaves when under load, as it is determined at 900 rpm's engine speed, instead of the 600 rpm's for RON. MON testing uses a similar test engine to that used in RON testing, but with a preheated fuel mixture, higher engine speed, and variable ignition timing to further stress the fuel's knock resistance. Depending on the composition of the fuel, the MON of a modern gasoline will be about 8 to 10 points lower than the RON, but there is no direct link between RON and MON. Normally, fuel specifications require both a minimum RON and a minimum MON. Anti-knock index: in most countries, including Australia, New Zealand and all of those in Europe, the headline octane rating shown on the pump is the RON, but in Canada, the United States, Brazil, and some other countries, the headline number is the average of the RON and the MON, called the anti-knock index/2. It may also sometimes be called the pump octane number. Difference between a RON and AKI: because of the 8 to 10 point difference noted above, the octane rating shown in Canada and the United States is 4 to 5 points lower than the ratings shown elsewhere in the world for the same fuel. This difference is known as the fuel sensitivity, and is not typically published for those countries that use the anti-knock index labeling system. See the table in the following section for a comparison. Observed road octane number: another type of octane rating, called observed road octane number, is derived from testing gasolines in real-world multi-cylinder engines, normally at wide-open throttle. It was developed in the 1920s and is still reliable today. The original testing was done in cars on the road, but as technology developed, the testing was moved to chassis dynamometers with environmental controls to improve consistency. Aviation gasoline octane ratings: gasoline used in piston aircraft common in general aviation have slightly different methods of measuring the octane of the fuel. Similar to AKI, it has two different ratings, although it is referred to only by the lower of the two. One is referred to as the aviation lean rating and is the same as the MON of the fuel up to 100. The second is the aviation rich rating and corresponds to the octane rating of a test engine under forced induction operation common in high-performance and military piston aircraft. This utilizes a supercharger, and uses a significantly richer fuel-air ratio for improved detonation resistance. The most commonly used current fuel 100LL, has an aviation lean rating of 100 octane, and an aviation rich rating of 130. Examples: the RON-MON values of N-heptane and isooctane are exactly 0 and 100, respectively, by the definition of octane rating. The following table lists octane ratings for various other fuels. Effects: higher octane ratings correlate to higher activation energies, this being the amount of applied energy required to initiate combustion. Since higher octane fuels have higher activation energy requirements, it is less likely that a given compression will cause uncontrolled ignition, otherwise known as autoignition or detonation. The compression ratio is directly related to power and to thermodynamic efficiency of an internal combustion engine. Engines with higher compression ratios develop more area under the Otto cycle curve, thus they extract more energy from a given quantity of fuel. During the compression stroke of an internal combustion engine, as the air/fuels mix is compressed, its temperature rises. A fuel with a higher octane rating is less prone to auto-ignition and can withstand a greater rise in temperature during the compression stroke of an internal combustion engine without auto-igniting, thus allowing more power to be extracted from the Otto cycle. If during the compression stroke the air/fuel mix reaches a temperature greater than the auto-ignition temperature of the fuel self-or auto-ignites. When auto-ignition occurs, the uprising piston is then attempting to squeeze the rapidly heating fuel charge. This will usually destroy an engine quickly if allowed to continue. There are two types of induction systems on internal combustion engines, normally aspirated engine, or forced induction engines. In the case of the normally aspirated engine, at the start of the compression stroke the cylinder air/fuel volume is very low, this translates into a low starting pressure. As the piston travels upward, abnormally high cylinder pressures may result in the mixture auto-igniting or detonating, which is why conservative compression ratios are used in consumer vehicles. In a forced induction engine where at the start of the compression stroke the cylinder pressure is already raised exp 202 kPa, the starting pressure or air/fuel volume would be 2 times that of the normally aspirated engine. This would translate into an effective compression ratio of 20:1 versus 10:1 for the normally aspirated. This is why many forced induction engines have compression ratios in the 8:1 range. Many high-performance engines are designed to operate with a high maximum compression, and thus demand fuels of higher octane. A common misconception is that power output or fuel efficiency can be improved by burning fuel of higher octane than that specified by the engine manufacturer. The power output of an engine depends in part on the energy density of the fuel being burnt. Fuels of different octane ratings may have similar densities, but because switching to a higher octane fuel does not add more hydrocarbon content or oxygen, the engine cannot develop more power. However, burning fuel with a lower octane rating than that for which the engine is designed often results in a reduction of power output and efficiency. Many modern engines are equipped with a NOx sensor, which sends a signal to the engine control unit, which in turn retards the ignition timing when detonation is detected. Retarding the ignition timing reduces the tendency of the fuel-air mixture to detonate, but also reduces power output and fuel efficiency. Because of this, under conditions of high load and high temperature, a given engine may have a more consistent power output with a higher octane fuel, as such fuels are less prone to detonation. Some modern high-performance engines are actually optimized for higher than pump premium. The 2001 to 2007 BMW M3 with the S54 engine is one such car. Car and Driver magazine tested a car using a dynamometer, and found that the power outputs increased as the AKI was increased up to approximately 96 AKI. Most fuel filling stations have two storage tanks. Those motorists who purchase intermediate-grade fuels are given a mixture of higher and lower octane fuels. Premium grade is fuel of higher octane, and the minimum grade sold as fuel of lower octane. Purchasing 91-octane fuel simply means that more fuel of higher octane is blended with commensurately less fuel of lower octane, than when purchasing a lower grade. The detergents and other additives in the fuel are often, but not always, identical. The octane rating was developed by chemist Russell Marker at the Ethyl Corporation in 1926. The selection of N-heptane as the 0 point of the scale was due to its availability in high purity. Other isomers of heptane produced from crude oil have greatly different ratings. Regional variations. The selection of octane ratings available at the pump can vary greatly from region to region. Australia, regular unleaded fuel is 91 RON, premium unleaded with 95 RON is widely available, and 98 RON fuel is also reasonably common. Shell used to sell 100 RON petrol from a small number of service stations, most of which are located in major cities. United Petroleum sells 100 Romanian lei unleaded fuel at a small number of its service stations. All fuel in Australia is unleaded except for some aviation fuels. Bahrain, 91 and 95, standard in all petrol station in the country and advertised as for regular or 91 and for premium or 95. China, 93 and 97 are commonly offered. In limited areas higher ratings such as 99 Romanian lei is available. In some rural areas it can be difficult to find fuel with over 93 Romanian lei. Chile, 93 Romanian lei, 95 Romanian lei and 97 Romanian lei are standard at almost all gas stations throughout Chile. The three types are unleaded. Colombia, Ecopetrol. Colombia's monopoly of refining and distribution of gasoline establishes a minimum AKI of 81 octanes for corriente gasoline and minimum AKI of 87 octanes for extra gasoline. Costa Rica, Recope, Costa Rica's distribution monopoly, establishes the following ratings, plus 91 and super. Croatia, all fuel stations offer unleaded Euro Super BS 95 Romanian lei fuel. Many also offer Euro Super Plus BS 98 Romanian lei. Some companies offer 100 Romanian lei fuel instead of 98. Cyprus, all fuel stations offer unleaded 95 and 98 Romanian lei and a few offer 100 Romanian lei as well. Denmark, 95 and 98 Romanian lei are common choices. Some varieties of low-percentage ethanol mixtures are offered at larger gas stations. E85 is being implemented but has yet to be finalized in the parliament. Ecuador, extra with 87 and super with 92 are available in all fuel stations. Extra is the most commonly used. All fuels are unleaded. Egypt, 80 Romanian lei is commonly used for all old cars. 90 Romanian lei and 92 Romanian lei are available at almost all gas stations with a negligible price difference between them. 95 Romanian lei is becoming more common, especially in the big cities and upscale suburbs. All fuels are unleaded. Most cars in Egypt use 92 Romanian lei, while 90 Romanian lei is becoming extremely unused by the public. 95 Romanian lei is becoming very expensive compared to 90 Romanian lei, and 92 Romanian lei therefore also becoming unused. Finland, 95 and 98, advertised as such, at almost all gas stations. Most cars run on 95, but 98 is available for vehicles that need higher octane fuel, or older models containing parts easily damaged by high ethanol content. Shell offers V-Power, advertised as over 99 octane, instead of 98. In the beginning of 2011, 95 RON was replaced by 95 E10 containing 10% ethanol, and 98 RON by 98 E5, containing 5% ethanol. ST1 also offers a E85 on some stations, which is 85% ethanol made from biodegradable waste. A E85 is only suitable for flexible cars that can run on high percentage ethanol. Germany, Super E10 95 RON and Super Plus E5 98 RON are available practically everywhere. Big suppliers such as Shell or Aral offer 100 RON gasoline at almost every fuel station. Normal 91 RON is only rarely offered because lower production amounts make it more expensive than Super 95 RON. Due to a new European Union law, gas stations are being required to offer a minimum rate of the new mixture of Super 95 Romanian lei with up to 10% ethanol branded as Super E10. Producers are discontinuing Super E5 95 Romanian lei with less than 5% ethanol, so cars that are unable to use E10 must use 98 Romanian lei petrol instead. Greece, 95 Romanian lei, 97 plus and 100 Romanian lei unleaded offered by some companies. Also available Super LRP 96 Romanian lei for older vehicles. Hong Kong, only 98 RON is available in the market. There have been calls to reintroduce 95 RON, but the calls have been rejected by all petrol station chains, citing that 95 RON was phased out because of market forces. India's ordinary and premium petrols are of 91 Romanian lei. The premium petrols are generally ordinary fuels with additives, that do not really change the octane value. Two variants, Speed 93, and Speed 97, were launched, with RON values of 93 and 97. India's economy class vehicles usually have compression ratios under 10:1, thus enabling them to use lower octane petrol without engine knocking. Indonesia's premium petrol rated at 88 Romanian lei and being subsidized, it cost only about 65 cents per litre. Other options are Pertamax rated at 92 Romanian lei and the Pertamax Plus rated at 95 Romanian lei. Pertamax Racing Fuel, a bioethanol flex fuel rated at 100 Romanian lei. Total and Shell stations only sell 92 Romanian lei and 95 gasoline. Ireland, 95 RON unleaded is the only petrol type available through stations, although E5 is becoming more commonplace. Italy, 95 RON is the only compulsory gasoline offered, only a few fuel stations offer 98 RON as the premium type. Many Shell and Tomoil stations close to the cities offer also V-Power gasoline rated at 100 RON. Recently Egypt introduced Blue Super Plus, a 100 Romanian lei gasoline. Israel, 95 RON and 98 RON are normally available at most petrol stations. 96 RON is also available at a large number of gas stations, but 95 RON is more preferred because it's cheaper and performance differences aren't very wide and noticeable. Regular fuel is 95 RON. All variants are unleaded. Japan, since 1986, regular is greater than or equal to 89 RON, and high octane is greater than or equal to 96 RON, lead-free. Those values are defined in standard JISK 2202. Sometimes high octane is sold under different names, such as F1. Latvia, 95 Romanian lei and 98 Romanian lei widely available. Lebanon, 95 Romanian lei and 98 Romanian lei are widely available. Lithuania, 92 Romanian lei, 95 Romanian lei and 98 Romanian lei widely available. In Lukoil gas stations E85 gasoline, 98 E15, 98 E25 are available. Malaysia had 92 Romanian lei until September 2009. Replaced with regular unleaded fuel RON 95 RON, premium fuel is rated at 97 RON. MA copyright Zico, Pemex Magna is sold as a regular fuel and is available at every station. And Pemex Premium is sold at almost all gas stations. Both variants are unleaded. Montenegro, 95 Romanian lei is sold as a regular fuel. As a premium fuel, 98 Romanian lei is sold. Both variants are unleaded. Netherlands, 95 RON euro is sold at every station, whereas 98 RON Super Plus is being phased out in favor of premium fuels, which are all 95 Romanian lei fuels with extra additives. Shell V-Power is a 97 RON. Some independent tests have shown that 1 year after introduction it was downgraded to 95 Romanian lei, whereas in neighboring Germany Shell V-Power consists of the regular 100 RON fuel. New Zealand, 91 RON regular, and 95 RON premium are both widely available. 98 RON is available instead of 95 RON at some service stations in larger urban areas. Philippines, a brand of Petron Blaze is rated at 100 Romanian lei. Other super premium brands like Petron XCS, Coltex Gold, Shell V-Power are rated at 95 Romanian lei to 97 Romanian lei, while Petron Extra Unleaded, Coltex Silver, and Shell Super Unleaded are rated at 93 Romanian lei. Poland, Euro Super 95 is sold in every gas station. Super Plus 98 is available in most stations, sometimes under brand and usually containing additives. Shell offers V-Power racing fuel which is rated 100 Romanian lei. Portugal, 95 Romanian lei euro is sold in every station and 98 Romanian lei super being offered in almost every station. Russia and CIS countries, 80 RON is the minimum available, the standard is 92 RON and 95 RON. 98 RON is available on some stations but it's usually quite expensive compared to the lower octane rating fuels. Saudi Arabia, 2 types of fuel are available at all gas stations in Saudi Arabia. Premium 91 inches where the pumps are colored green, and Super Premium 95, where the pumps are colored red. While gas stations in Saudi Arabia are privatized, the prices are regulated by the authorities and have a fixed at SAR 0.45 and SAR 0.60 per litre respectively. Prior to 2006, only Super Premium 95 Romanian lei was available and the pumps weren't colored in any specific order. The public didn't know what octane rating was, therefore big educating campaigns were spread, telling the people to use the red gas only for high-end cars, and save money on using the green gas for regular cars and trucks. Singapore, all 4 providers, Coltex, ExxonMobil, SPC and Shell have 3 grades of petrol. Typically, these are 92, 95, and 98 Romanian lei. However, since 2009, Shell has removed 92 Romanian lei. South Africa, regular unleaded fuel is 95 Romanian lei in coastal areas. Inland regular unleaded fuel is 93 Romanian lei. Once again most fuel stations optionally offer 95 Romanian lei. Spain, 95 Romanian lei euro is sold in every station with 98 Romanian lei super being offered in most stations. Many stations around cities and highways offer other high-octane premium brands. Sri Lanka, in Shepatco filling stations, 92 Romanian lei is the regular petrol and 95 Romanian lei is called super petrol, which comes at a premium price. In LIOC filling stations, 90 Romanian lei remains as regular petrol and 92 Romanian lei is available as premium petrol. The cost of premium petrol is lower than the cost of super petrol. Sweden, 95 Romanian lei, 98 Romanian lei and E85 are widely available. Taiwan, 92 Romanian lei, 95 Romanian lei and 98 Romanian lei are widely available at gas stations in Taiwan. Thailand, 91 Romanian lei and 95 Romanian lei are widely available. 91 Romanian lei benzene petrol withdrawn on January 1, 2013 to increase uptake of gasohol fuels. Trinidad and Tobago, 92 Romanian lei and 95 Romanian lei are widely available. Turkey, 95 Romanian lei and 98 Romanian lei are widely available in gas stations. 92 Romanian lei has been dropped in 2006. Ukraine, the standard gasoline is 95 Romanian lei, but 92 Romanian lei gasoline is also widely available and popular as a less expensive replacement for 95 Romanian lei gasoline. 80 Romanian lei gasoline is available for old cars and motorcycles. United Kingdom, regular petrol has an octane rating of 95 Romanian lei, with 97 Romanian lei fuel being widely available as the super unleaded. Tesco and Shell both offer 99 Romanian lei fuel. In April 2006, BP started a public trial of the super high-octane petrol BP Ultimate Unleaded 102, which as the name suggests, has an octane rating of 102 Romanian lei. Although BP Ultimate Unleaded and BP Ultimate Diesel are both widely available throughout the UK, BP Ultimate Unleaded 102 was available throughout the UK in only 10 filling stations, and was priced at about 2.5 times more than their 97 Romanian lei fuel. In March 2010, BP stopped sales of Ultimate Unleaded 102, citing the closure of their specialty fuels manufacturing facility. Shell V-Power is also available, but in a 99 Romanian lei octane rating, and Tesco fuel stations also supply the Greenergy-produced 99 Romanian lei Momentum 99. United States, in the U.S. octane rating is displayed in AKI. In the Rocky Mountain states, 85 AKI is the minimum octane, and 91 AKI is the maximum octane available in fuel. The reason for this is that in higher elevation areas, a typical naturally aspirated engine draws in less air mass per cycle because of the reduced density of the atmosphere. This directly translates to less fuel and reduced absolute compression in the cylinder, therefore deterring knock. It is safe to fill a carbureted car that normally takes 87 AKI fuel at sea level with 85 AKI fuel in the mountains, but at sea level the fuel may cause damage to the engine. A disadvantage to this strategy is that most turbocharged vehicles are unable to produce full power, even when using the premium 91 AKI fuel. In some East Coast states, up to 94 AKI is available. As of January 2011, over 40 states and a total of over 2,500 stations offer ethanol-based E85 fuel with 105 AKI. Often, filling stations near U.S. racing tracks will offer higher octane levels such as 100 AKI. Venezuela, 91 Romanian lei and 95 Romanian lei gasoline is available nationwide, in all PDV gas stations. 95 Romanian lei petrol is the most widely used in the country, although most cars in Venezuela would work with 91 Romanian lei gasoline. This is because petrol prices are heavily subsidized by the government. All gasoline in Venezuela is unleaded. Vietnam, 92 is in every gas station and 95 is in the urban areas. Zimbabwe, 93 octane available with no other grades of fuels available. E10, which is an ethanol blend of fuel at 10% ethanol, is available. The octane rating however is still to be tested and confirmed, but it is assumed that it's around 95 octane. E85 available from 3 outlets with an octane rating AKI index of between 102 to 105 depending on the base petrol the ethanol is blended with. See also, AVAS, cetane number, references. Further reading, SAE Standard J1297 Alternative Automotive Fuels, September 2002, Koo, Kenny K. Understanding Octane and its Related Components. Yellowknife, Smithsonian Press, 2006. External links, octane ratings of some hydrocarbons, petroleum and coal, gasoline refining and testing. Information in general, why are octane levels important, gasoline FAQ, how octane works at howstuffworks.com.